simple analysis for how we can go through different quadrants of this class E chopper. But this is very simplified because we assume that these two switches are on at the same time and these two switches are on at the same time. Okay, first I want you to understand this part and see like how the current and voltage changes, and then once you understand this part, then maybe you can think about the next switching order that I'm gonna show here. Okay, so let's assume that here first we have switch 1 and switch 2 on. Okay, when switch 1 and switch 2 on, we already saw that VO is going to be equal to VDC, Vs, and current is going to increase, right? Current increases. Current is going to increase in the positive direction. So this is when switch 1 and 2 are closed. This is what we have, right? And the current is going to increase. We are energizing the inductor. Now let's assume that S1 and S2 are not synchronized again. So let's assume that S1 goes off, but S2 is still on. Okay, so we don't have S1 conducting anymore, but S2 is still on. So how this current, it's gonna close the loop? It's gonna close the loop through D4, right? So D4 and S2 are gonna conduct. What's the voltage across the load? It's gonna be 0. What happens to the current? It's gonna decrease, right? The energy stored in this inductor, it's gonna release itself. It's gonna current, it's gonna decrease. Okay. Then let's assume that at this point S2 goes off as well, right? So D3 and D4 in this case are gonna conduct the current, right? We first assume that we go from this switch, from this state directly to this state, right? But it just like we might have two switches that are not synchronized. One of them might go off or on before the other one. So in this case, VO becomes equal to negative Vs. What happens to the current, right? Current is still gonna decrease, right? But it basically increases negatively, okay? So that's basically what happens here, right? So in all of these three cases, current is positive. Current is decreasing here. It's like trying to reach, sorry, I made a mistake. Current is decreasing. It's trying to reach 0, right? Basically releasing itself here. So we are in the positive current mode, right? Current is positive. In this case, we are in the first quadrant. In this case, we are in the fourth quadrant. Okay. And then say we have S3 and S4 on. Okay, so in this case, when S3 and S4 on, we already discussed that. So this is actually, it's gonna go from here, and this is gonna go from here, right? So it's gonna go from here, sorry, it's gonna go from here. So at this point, VO, it's gonna be equal to negative Vs, and the current, it's gonna be negative. So here, like this is current is positive. For these ones, current would be negative. VO is equal to negative Vs. Current is negative and it's increasing in the negative direction. Then after that we can have, let's say like S3 goes off, like then still S4 is on, right? But S3 goes off. So we have current going through the inductor in this direction, S4 is on. This current, it's gonna close itself through D2, right? So D2 and S4 are gonna conduct the current, VO becomes 0. And finally, again, we would have D1 and D2 on. So both S4 and S4 go off, and D1 and D2 will be conducting, and then VO becomes equal to positive Vs, right? So we see that like for both cases, when current is positive, VO can be either 0, can be Vs, or can be negative Vs. When current is negative, VO can be negative V sub S, 0, or V sub S, okay? So there are many different cases that we discussed here. So sometimes like we don't want to directly go from one state to another state, so from here to here, right? Because let's assume that, okay, I want to draw this one more time and tell you why we don't want to go sometimes directly from this state to this state. Or from one state like that we discussed before to another state. So like this is what we have. This is what we have here. Okay, so here we are in the motoring state. Here we're gonna be in the generating state. Again, here we are in the motoring state. Here we're gonna be in the generating state. So when, like, let's say like first we have from we are in this state, and S1 and S2 are on, okay? We are storing some energy here, right? But let's say that the current that goes through the inductor, it's not that much, right? It's not that much, right? And the voltage across this is not that much either, right? So like let's say like the speed is very low, so it doesn't generate that much voltage. And if you just like go directly from this state to this